Okay, guys, I'm back again. This is JJ Tech Tutoring. I'll be taking you guys through exact differential equation. Guys, exact differential equation is an easy method whereby you need to just master and just focus with the process. I'll take you through patiently, and I'll try by all means to be conspicuous and make sure that I also show you some fictitious techniques that you can be able to check if it's exact. Then you will have the skills to distinguish between exact, homogeneous, separable, and linear or binomial. Right. Now let us focus on exact. Exact is said to be an exact equation if the expression on the left-hand side is an exact differential with the right-hand side. Right. So the standard form of an exact is exactly the same with the standard form of homogeneous. This is the standard form of homogeneous and exact. Right. So what you need to know here is that if you derive mxy and nfxy partially, are you going to get the same answer? Now, if del m over del y is equals to del n over del x, this makes these things to be exact, right? So this is basically what you need to do to can prove exact, right? So in the method of solution, del m over del y and del n over del x, if they are the same, you need to now say del f over del x is equals to m and del f over del y is equals to n, right? Then between the two, you must choose which one is it integratable or is it easy to integrate. Then you pick that one which you find it easy for you to integrate. So that means now you have to go with your convenience and your comfortability in integrating. If ever you think m or mxy is hard for you to integrate, you have to go for nxy. The answers will be the same and the answers will be acceptable. Now, say what? Say you know how to integrate m. So that means you will pick this one and say is equals to m. You can just say m of xy. Then the question of exact always wants you to find the function. And then if the ODE or the DE is exact, that means it's a function. And then if it's a function, you are required to find that function. Then this f is your function. Then what is it that we can do here to find the function or to find f? We need to integrate here for us to find this f. And then we need to integrate with respect to x. Then both sides we're going to do the same thing. We have to integrate here. We have to integrate that side. So the integration of del f over del x is f of x y is equals to, so that means this will be integrated. Immediately we find or we write it in a numerical form or in a variable and numerical. So now the constant of this should be g of y because we integrated with respect to y or to x. So us integrating with respect to x makes us to actually use gy as the constant. Remember, guys, here we were supposed to put c, but then we placed g of y. That is the rule of exact, right? So now, after doing this, we need to take this part, right? This part, we don't want to erase it because it's very important that at the end of the solution, we need to bring it back and write it, right? We need to take this part and derive it with respect to y, right? We need to take this part and derive it with respect to y, right? So obviously, at the left-hand side, we'll have df or del f over del y is equals to del y. We're gonna derive this part, right? You will see it clearly when we're doing examples. We're gonna derive this part, and then this part is going to be derived x and y, dx. Then the derivative of g of y is just g prime of y. Now, what is it that we need to do at this point. There is something that I just discovered now. That this look like this. I'm not sure. Check it. Yes, del f and del y, and also del f and del y. And then we did this del f over del y, trying to derive this with respect to y. So now we need to put this n off. We need to put this n off. We need to put this n here. So that means it will be n of x and y is equals to del y m x y dx plus g prime of y. Right. Then from here, we need to find g of y. From here, we need to find g of y. How do we find g of y? We integrate here with respect to y. Right? Because if we integrate g prime y, we get gy. Right? So this is what we're going to do. So we'll integrate nxy. We'll integrate nxy. We'll integrate n of xy. And we're going to integrate here with respect to y. Then plus here we'll have gy. Right? Then from there, you solve for gy here. After finding the solution for gy, you just have to take this to this side. You have to say integral n xy minus integral m xy. Then they will give you gy. Then you put the answer here. Now, let us solve an example. That's where we'll understand it better. Let us solve an example. That's where we'll understand it better. Say what? Say 2xy plus 4 all into brackets dx plus x squared minus 1 dy is equals to 0. Now, your m obviously is this side and your n is this side, right? So del m over del y is equals to 2x. Then del n over del y is equals to 2x. Del x, del x, del x, right? So now we are deriving this side with respect to y, then we get 2x. Then we derive this side with respect to x, then we get 2x. That means now del m over del y is equals to del n over del x is equals to 2x. This makes it an exact, right? And it being an exact, this makes it a function. And it being a function, this leads us to find a function, right? This is actually an exact. Right. Now, this means that del f over del x is equals to m. And del f over del y is equals to n. Right? So, we have to choose between these two. Right? Because let me just write. Let me not use this and just use them exactly. This is 2xy plus 4. This is x squared minus 1. Right? So you have to choose which one between the two that is easy to integrate according to you. According to you. Right? So now del f over del y for me is the easiest one to integrate. Right? So now integrate these two with respect to y. Right? Because we are looking for the function. We're looking for the function. This will give us f of x and y. This will give us, these are constants inside because we are respecting y. So it will be just x squared y minus y. Right? So what is it that we need? Because we need to add the constant here. Which kind of a constant will we add? This will be plus g of x because we integrated with respect to y. Then constant should be g of x. I know usually we use c as the constant, but then under exact, at least let us now use g of x. Don't worry, we'll use c, but then at this point let us use g of x. This is the first part of the solution, and this is the most important step, right? Now, after this step, you need to now derive with respect to x. We need to derive with respect to x because we integrated with respect to y. So now we have to say del f over del x is equals to x squared y minus y. No, actually we need to derive once. We need to derive them once. So this one will be 2x y. Then this one is a constant, right? This part is a constant, and then we're deriving with respect to x. That means it won't be derived, it will be 0. Then plus g prime x. G prime x. Now, what you see here is that now we have del f over del x, and then here on top we had something like that as well. Is this not del f over del x? And then is this not del f over del x? Then that means we need to say 2xy plus 4 is equals to 2xy plus g prime of x. Right. So now what is it that we need to do from here? This will cancel this because it will say 2xy minus 2xy. Then it will be 4 is equals to g prime x. Right. So from there, we need to solve for g of x, this one, because I said this is the most important step. So that means our final answer is going to be like f of xy is equals to x squared y minus y plus g of x. Right? This is our final answer. But then now we are still looking for g of x for us to plug it here. Right? So this is not g of x, it's g prime x. Right? So we need to derive, integrate both sides by x for us to get a g without a prime. So integral of 4 dx is 4x is equals to gx plus c. Right? So you can just say 4x minus c is equals to g of x. Right? So this part is the one that is going to represent g. Right? So final answer will be f of x y is equals to x squared y minus y plus 4x minus 1. 4x minus 1. Then this will be our final answer. Don't forget, guys, subscribe. Don't forget to subscribe. Subscribe, please. And thank you. Good luck on your exams and good luck on practicing and finding it easy for you to take out the question on your exam. Don't forget to drop any kind of a comment on your on the comment section, whether you want to ask for elaboration, whether you want to ask any number that you wish or any number that you want me to do for you. I will do it for you clearly and try to explain.